Hey everyone, and welcome to week 2 of distance learning. Last week, you guys learned about the law of sines and law of cosines. This week, since it's a shorter week and spring break is next week, it's going to be a smaller lesson. All right, so let's get started. Our learning target this week is that I can evaluate inverse trigonometric functions. So the first thing that we have to unpack here is this idea of an inverse. Way back in Unit 1, we talked about inverses as the flip of x and y. So we saw them as ordered pairs. So if the function was x comma y, the inverse is y comma x, and the domain and the inverse switch. And so the symbol is f inverse of x. And we also talked about how to take the inverse as being able to flip the operations. So if we have 4x minus 2, we multiplied by 4 minus 2, and we got 4x minus 2. So to undo it, we add 2 and divide by 4. Now, we're not going to go back and talk about inverse functions in that regards, but this is where this topic is starting from. So again, if you remember, inverse is essentially switching the x and the y values or undoing the initial equation. I like that idea better. It's the how do we undo it? So in this one, it's multiplication, so you divide. This one, it's subtraction, so you add. It's the inverse operation, inverse function. It's how you undo the function. So that brings us to the question, how do we take the inverse of trig functions? Before we do that, though, let's just talk about the horizontal line test. So in order to have an inverse, your function has to pass the horizontal line test. That is, you can't have multiple intersections when you go through it with a horizontal line. So because sine and cosine, you intersect at many points horizontally, you technically can't take the inverse, which is why we're going to talk about a restricted domain, and we're only going to look at sine from negative pi over 2 to pi over 2. And so in this case, because we're restricting the domain, we can take the inverse, because if I draw a horizontal line through it, it only intersects at one point. All right, so similar to last week, we're now going to watch a YouTube video where I pause throughout so we can kind of get a better understanding of what the inverse trig functions are.
Professor Dave again. Let's talk about inverse trig functions. He knows a lot about all kinds of stuff. Professor Dave explains. We know about the 6 trigonometric functions, and we know about inverse functions. So it's time to learn about inverse trigonometric functions. Let's recall that when trying to find the inverse of a function, like f of x equals root x, we change this into a y, and then we make x and y swap places. Then we solve for y. In this case, that would involve squaring both sides, which gives us y equals x squared.
So the way that we did it is that we said, okay, how do you undo the square root? You square both sides. Same thing.
Essentially, inverse functions sequentially undo anything operating on x in the original function. Now let's try y equals sine x. If we swap the variables, how do we solve for y? The only way to do this is to take the inverse sine of both sides. This will cancel out the sine operating on y, and we get y equals inverse sine x. We must note that inverse sine x is not the same thing as 1 over sine x.
Inverse sine x is a function. We call it arc sine or arc cosine, and he's correct. It's not the same as 1 over sine, and you'll see why. 1 over sine is technically cosecant.
If we had the quantity sine x to the negative 1 power, that would equal 1 over sine x, which we already know is cosecant x. Instead, when we have the negative 1 here, it's the inverse sine function. And rather than sine x, where you plug in an angle and get a sine value, for inverse sine x, you plug in a valid sine value and it gives you the angle that generates it. Inverse sine can also be represented this way, as arc sine x.
So I want to say that again. So when we evaluated just sine, the x value or the theta value, as I used in class, was the angle. So you input the angle and you get the value outside of it. When it's the inverse, you put in the sine value and you get the angle when you get it out. So you just flip where the angle is.
We should quickly note that in order for a function to have an inverse function, it must pass the horizontal line test, because when we find the inverse, we are reflecting the function across the line y equals x, and whatever we get must pass the vertical line test to be considered a function. So sine x as a whole does not have an inverse function, but we will instead look at a restricted domain for this function, from negative half pi to half pi.
So again, that's what we talked about earlier. Because the sine function doesn't pass the horizontal line test, we have to restrict the domain in order to take the inverse. So if we restrict it from negative pi over 2 to pi over 2, it does pass the horizontal line test.
This section does pass the horizontal line test, and it is the inverse of this section that gives us the inverse sine function.
So he just reflected it, and so this new graph is what inverse sine looks like.
Which will look like this. The domain of this function will be negative 1 to 1, because those are the only sine values that are possible. The range will be...
So domain and range switch for sine and arcsine. So for sine, the range is negative 1 to 1. Right? So for sine, the range is negative 1 to 1. So for arcsine, the domain is negative 1 to 1. And the domain for regular sine, we restricted it from negative pi over 2 to pi over 2. So now the range for arcsine is negative pi over 2 for pi over 2.
Negative half pi to half pi, because those are the angles we get when we plug in each possible unique sine value. So let's make sure we know how to evaluate these. What is the inverse sine of root 2 over 2? Well, if we recall our unit...
So note real quick that he put the value on the inside, and so what we're going to get out is the angle.
Circle. The angle that gives a sine of root 2 over 2 is quarter pi. So the inverse sine of root 2 over 2 is quarter pi.
So that's how I mainly suggest we do this, is to use the unit circle, but sometimes they're going to give you values that aren't on the unit circle. So you can use the calculator. And we're going to do that in just a second.
Now let's move on to inverse cosine. This will be the inverse of cosine x from 0 to pi. This is a different restriction than we had for sine, because sine goes from negative 1 to positive 1 as it moves through quadrants 4 and 1. Cosine spans all the possible values from 1 to negative 1 as it goes through quadrants 1 and 2. So we take the graph of cosine x from 0 to pi and we reflect it across the line y equals x to get the inverse cosine function.
So this is inverse cosine. So real quick, I'm going to change slides. We'll deal with that in a second. So the reason why sine was from negative pi over 2 to pi over 2 is because for sine, the y values, point. So sine is the y value. So sine goes from negative 1 to 1, from negative pi over 2 to pi over 2. So that's why sine, we restrict it that way. Cosine goes from 1 to negative 1, from 0 to pi. So it's a different restriction. Let me get back.
Professor David, sine x as a whole of this function. Now let's move on to inverse cosine. This will be the inverse of cosine x from 0 to pi.
So this is, again, he's explaining
different restriction than
why it's a different restriction.
Because sine goes from negative 1 to positive 1 as it moves through quadrants 4 and 1. Cosine spans all the possible values from 1 to negative 1 as it goes through quadrants 1 and 2. So we take the graph of cosine x from 0 to pi and we reflect it across the line y equals x. And again,
the domain switches. So we said that the domain is from -1 to 1 because that was the range before, and we flipped the range and domain.
Inverse cosine function. As we would expect, the domain is -1 to 1, and the range is 0 to pi. What is the inverse cosine of -1/2?
So we're going to find -1/2 on the unit circle.
In this interval that gives a cosine value of -1/2. And if we remember the unit circle, we know that must be 2/3 pi. Now let's look at inverse tangent. Starting with tangent x, we see that we will want to restrict things to within -1/2 pi and 1/2 pi, so that it passes the horizontal line test. Now, to get the inverse tangent function, we reflect across y equals x, and we get this. Now the domain is all real numbers, while the range is -1/2 pi to 1/2 pi, since those are the angles we get when we plug in all the possible tangent values, which go towards positive and negative infinity as cosine gets very small. These are trickier to evaluate in your head, but sometimes we can do it, like the inverse tangent of √3. We might realize that the angle that produces a tangent of √3 must have a sine value over a cosine value that equals √3.
So for tangent, it's a little bit tricky because we're not given the tangent. If you remember, they also follow a pattern. But this is the value that we want to get. Tangent is sine over y. So what tangent is sine over cosine. So what sine over cosine is going to give you √3? Well, we know that √3 over 2 over 1/2 gives us √3. So that's why this is pi over 3.
And of the common angles, that must be a third pi, since √3 over 2 divided by 1/2 is the same as √3 over 2 times 2, which equals √3. Luckily, rather than having to evaluate inverse trig functions by hand, we can always just plug them into a calculator.
All right, so that's what we're going to do. We're going to use Google Calculator. Okay, I'm here. We're on Google Calculator. So we have radian and degree. It doesn't matter which one you're in, but it's going to give you different answers. So radian is going to give you the simplified like pi over 3, and then degree is going to give you the angle. So if we hit the inverse and we hit sine, and we do 1/2, which is 0.5, the radian is 0.5235, but that's really pi over pi over 6. So if I type in pi over 6, that's what I get. So that's what the radian is telling you. So as we were saying, if you type in here, that 0.523 is really pi over 6. Now, if you do the same thing, if I clear this all out, if you do the same thing in degree and hit arcsine and do 0.5, if I do inverse sine 0.5, it's going to give me 30 degrees. So you can either do it in degrees or in radians. All right, back to this. All right, so now back to the unit circle. Like I said, sine of 1/2, you go to the unit circle. Where is the y value 1/2? It's pi over 6. Cosine of √3 over 2 is the same thing, because where is cosine √3 over 2? It's pi over 6. Where is tangent 1? Pi over 4, because √2 over 2 over √2 over 2 is 1. So that's the lesson for this week, just being able to evaluate sine inverse, cosine inverse, tan inverse, also known as arcsine, arccos, and arctan. So what are we doing next? You have only one practice in Khan Academy, and then the Google form, which will be on Google Classroom. All right, my friends, keep up the good work. As always, comment if you have questions. Let's just go back to our learning target. Simple. I can evaluate inverse trigonometric functions. You're going to do this using the unit circle or the calculator. Again, Khan Academy, you have one practice. It's linked here. And then you have the Google form workspace. And this is all going to be due April 9th, just because I don't want you guys having to work on Good Friday and the holiday. All right, my friends, keep up the good work. As always, comment if you have questions.